Alright, so today we're going to be looking at writing rational numbers in equivalent forms. Let's start with the definition. A rational number is any number that can be written as a fraction. So for example, n over d, where n and d are integers and d is not equal to 0. If you remember, when we're working with fractions, we always want to make sure we put in our lowest terms, and this is called simplifying. And the goal of simplifying is to make sure that the numerator and the denominator are relatively prime. And relatively prime just means that the numbers have no common factors other than 1. When we're looking at rational numbers, the ones that are most confusing are decimals. Just keep in mind that decimals that terminate or end are actually rational numbers. To write a terminating decimal as a fraction, you're going to identify the place value of the last digit in the number. Then you're going to write all of the digits after the decimal point as the numerator with the place value as the denominator. So if we just look at a couple of examples, we have -3 2/10. This would be a terminating decimal because it comes to an end, and it's equivalent to having -32 over 10. If you have 0.16 with the repeating symbol, that is a repeating decimal, and it's actually equal to 1/6. So now let's look at writing a decimal as a fraction. So here we have 5 and 37/100. So if you're saying the number, that's really the key here. So when we're doing this, the 5 or the whole number can stay a whole number. Here, what I like to do is there's 2 numbers in the place value, so that 37 is going to go on top. And because then there's 2 place values over, they're in the hundredth spot, so it goes over 100, or you can think about the fact that there would be 2 zeros there. Now 37 is prime, so this would actually be in simplest form. So why don't you pause the video and try the next one on your own. So here we have 622 thousandths. So we're going to do 622. There are 3 digits behind the decimal point, so that means we need 3 zeros to make this into 1,000. Since these are both even, we can actually go ahead and simplify this a little bit further, at least by dividing everything by 2. So 622 divided by 2 is going to give me 311. Now 1,000 divided by 2 would be 500. Now I'm not sure about 311, but I'm pretty sure we can't reduce this any further. So we're going to say that this is fine for now. So let's look at just a couple more examples. If you want, go ahead and pause the video, try them out, and just check your work. So here we have 8 and 75/100, so it's going to be 8. 75 over 100, but we can reduce that. Divide each by 25. And that is going to give us 8 and 3/4. Here we have 2,625 10,000ths. Like I said, I like to remember and just count the number of zeros that I need according to my place value. Now here, each of these would be divisible by 25 again. So if you do 2,625 and you're dividing it by 25, you get 105. And 10,000 divided by 25 gives us 400. Each of these is divisible by 5. So this is going to be 21 over 80. And then that's as far as we can go. Now when we're going the other way and we want to write a fraction as a decimal, we can divide the numerator by the denominator, and we can do this using long division. So numerator over denominator, remember the numerator always goes inside and the denominator outside. So if we look at this example here, we have 11 divided by 9. Notice our 11 went inside the division sign, the 9 on the outside. Decimal points are lined up, much like when we're adding or subtracting. And we're just continuing down. Here, that 2 is going to keep repeating, making it 20, so that's why it ends up with a bar. So the fraction 11/9 is equivalent to the decimal 1.2 repeating. And that bar is what we use to indicate the repeating decimal. Now let's try a couple out. So let's do 7 divided by 20. So I'm going to do 7 on the inside, 20 on the outside. I'm going to add that decimal point behind my 7. And the 0. 20 can't go into 7, but 20 can go into 70 3 times, which gives us 60. We subtract, we get a remainder of 10. I'm going to add another 0, drop it down, making it 100. 20 goes into 100 5 times, so this would be equivalent to 35 hundredths. Now another way you could do this is actually getting the denominator equal to like 10, 100, 1000 if you can, but that won't always work, whereas the division will always work. So what I mean by that is we could have taken 7/20 and said, alright, well 7 times 5 is 100, or 20 times 5 is 100, so then 7 times 5 would be 35. So this would be 35 hundredths, which once again would be 0.35. Either one of those methods is fine. Why don't you pause the video and try 15/9 on your own. Now, 15/9 won't work like the last one. You can't make it into a multiple of 10, 100, or 1,000 or so on. So we're going to use the division, because division always works. 9 goes into 15 once. With 6 left over. 9 goes into 60 6 times, which would be 54, which leaves a remainder of 6. So if you notice, that 6 is going to keep repeating, so we would put the bar over the 6. So now let's look at a real-life application when we would convert between forms. Tommy had 13 hits and 40 at-bats for his baseball team. We want to know what his batting average is. And if you are not familiar, batting average is found by taking the number of hits divided by the total number of at-bats expressed as a decimal. So here he had 13 out of 40, his part out of the whole. So we're going to take 13 and divide it by 40. Add my decimal point, my 0. Now 40 can't go into 13, but it can go into 130. I like to estimate 4 goes into 13 3 times, because that would be 12. So this is going to be 120. I'm going to go ahead and subtract. Leaves us with 10. Add a 0. 40 can't go into 100 evenly, but it can go in twice, which would be 80, leaving us with 20. Now 40 goes into 200 5 times. Remainder of 0, so we're done. So his batting average would be 325 thousandths, which is a pretty decent batting average if you know anything about baseball.